Good afternoon, everyone. Welcome to this tutorial on checking normality in research data. And in your module 2, lesson 2, it says there that before conducting statistical tests, it's essential to check whether our data follows a normal distribution. So today, I'll guide you through three ways to test for normality. So we can check normality through use of histograms or your QQ plots using visual inspection. You can also check normality using skewness and kurtosis. And of course, the most robust way of checking it is through statistical normality tests like your Shapiro-Wilk test for small samples and Kolmogorov-Smirnov test for large samples. So before we start, we revisit first what is normality. So in statistics, normality refers to whether a data set follows a bell-shaped curve, also known as a normal distribution. So many parametric tests like your here for parametric tests like your t-test and ANOVA assume normality. So it is crucial to test this assumption before proceeding with data analysis because if the data is not normal, therefore we cannot use this parametric test or we cannot use t-test and we cannot use ANOVA. So we check normality primarily to determine the correct statistical test. Again, if normality is not met, we can use non-parametric alternatives such as your Mann-Whitney-U or Kruskal-Wallis test. But if normality is met, we can use parametric tests like your t-test or ANOVA. Another use of checking normality is to ensure valid research findings. So if you violate normality assumptions, this can lead to incorrect results. And of course, lastly, it helps in data transformation. If data is non-normal, we may need to transform it before proceeding. We need to transform, meaning we change it or tweak it a bit before proceeding. So we first do the first step. So checking using your um, nuts data here. So I have here a data on my research using an intervention. So I took first the pre-test of students before giving the intervention. Then after giving the intervention, I gave them a post-test. And I also computed for the gain scores. So here you will see that I will check first for their normality of pre-test. So why should we check the normality on pre-test results? Hindi ba dapat sa post-test results lang or sa gain? So pre-test results to ensure that um, the distribution for the group is normal, meaning uh, I don't have participants or students that have ceiling grades, sobrang tataas ng grades nila, or floor effects, so sobrang baba naman ng grades nila. So this is one way to check that as well. So we do the first step, checking normality with a histogram. So you press analyze here, descriptive statistics, and then frequencies. Then pre-selected na si pretest dito, but you can click that and click it again for pretest. And then you go to charts. So for charts, you just click this histogram and then press continue. And then OK to generate the histogram. Nakikita yung histogram natin. So let's look at the histogram. So this histogram, you observe the shape of the distribution. So a normal distribution should look like a symmetrical bell curve. So mukha ba siyang symmetrical bell curve ito? So if it is skewed or has extreme peaks, it may not be normally distributed. But for me, looking at this data, it looks like a symmetrical bell curve. So let's check for skewness and kurtosis. We measure the shape of our data distribution. So click Analyze, go for Descriptive Statistics, and click on Descriptives. So for Descriptives, select Pretest again, then Options, then click on Kurtosis and Skewness. Then Continue, and then OK. So the SPSS will generate skewness and kurtosis values here. Wait lang natin. Kita ba? Eh, wait lang. Ayan. So skewness here, you can see that it is negative 0.089. And we want a skewness close to zero, which suggests a normal distribution. So a positive skew means a longer right tail or right skewed, and a negative skew means a longer left tail or left skewed. So our negative 0.089 here is very close to zero and suggests a normal distribution. However, for kurtosis, we want a kurtosis value around 3, which indicates a normal distribution. So a higher than 3 means the data has heavy tails, or we call it leptokurtic. And a lower than 3, which what we have now, means the data is too flat or platykurtic. So if the skewness actually and kurtosis values are between negative 1 to 1, the data is approximately normal. So these are just approximate values. So we go to the robust way of doing it, checking with normality test, which is using your Shapiro-Wilk and Kolmogorov-Smirnov test. So you press on Analyze, Descriptive Statistics, go to Explore. So for Explore, you choose again your pretest, then you go to Plots, and then you go for Normality Plots with Test. Then press Continue, then press OK. So you will have here now the data on Kolmogorov-Smirnov and Shapiro-Wilk test. So which one should you choose, your Kolmogorov-Smirnov or your Shapiro-Wilk? So in your module, you will see that you will use Shapiro-Wilk for small sample sizes, which means you have a population, sample population less than 50. So in the data that I have, it's for 138 students. So I will be using Kolmogorov-Smirnov, which is for larger samples with a sample population greater than 50. So you look for the p-values under Shapiro-Wilk and Kolmogorov-Smirnov. So here you have zero point 0.2, and for Shapiro-Wilk you have 0.447. So if the p-value is greater than 0.05, the data is normal. So here you will see that the data is normal. It's zero point 0.2. Even if we use Shapiro-Wilk, it's still greater than 0.05. It is still normal. So if the p-value is less than 0.05, it means that the data is not normal. Just like how we reject your null hypothesis. So we reject the normality assumption if it is less than 0.05. Okay, so we check naman the next one. We analyze the gain. So we start again with the first step, which is checking the histogram. So let's check the gain scores, charts. Okay. So for the gain, is it normal or not normal? It looks somehow normal. Then we check for skewness. and kurtosis. So descriptive stat, descriptives, uh, we remove that. We go for gain options, kurtosis skewness. Okay, okay. So here you have skewness of 0.237 and kurtosis of 0.201. Mm. For skewness, it is bit near zero. For kurtosis, it is still far away from 3. So let's check on using your Shapiro-Wilk and Kolmogorov-Smirnov. So we use plots. Okay. Okay. So using Kolmogorov-Smirnov, it is zero point 0.1, which is greater than 0.05, meaning that the data is normal. So using the normal QQ plot of gain, you will see that it is very near the line, meaning it is normally distributed. We looked at those that are not normally distributed. We check for the post test using histogram. Okay. Using histogram, it looks not normal. We have an outlier here. If we use skewness and kurtosis for post test, let's check that. It's negative zero point 0.7 and 0.975. Negative zero point 0.7 is near zero. Kurtosis is very far from 3. And then lastly, we check using your normality plots with tests. Okay. Here you will see Kolmogorov-Smirnov p-value of 0.026 and Shapiro-Wilk of 0.001. These are less than 0.05. So this is a good example of reject, or that the data is less than 0.05, which means that our data is not normally distributed. So therefore, we reject the null hypothesis. This is not normally distributed. So before we wrap up this tutorial, here are some questions to reflect on. First is, what are the methods for testing normality? And what is the best method of testing normality? What would you do if your data is not normally distributed? And third, how does normality impact the choice of statistical tests in research? So in this tutorial, you've learned how to check for normality using 3 ways: histograms, skewness and kurtosis, and statistical tests like Shapiro-Wilk and Kolmogorov-Smirnov. So understanding this normality helps ensure you choose the correct statistical test, leading to an accurate and valid research findings. Thank you for watching.